Yes, students, good evening. So this is Ajay sir here to explain some PYQs from the chapter Electric Charges and Fields. So what we'll be doing is we'll first read the question, look at the options, and we'll try to recollect the concept, okay, from which or on which the question is based. We'll discuss a little bit about the concept and then apply it to this question. Okay. So let's begin. The first question here says there are two metallic spheres of radii 1 centimeter and 3 centimeters. Now, whenever you read through a question, no, make it a habit to understand each term carefully. Okay. Now, they are saying that there are two metallic spheres. What is a metal? Metals are conductors. So, they are talking about conducting spheres. Fine. They have given radii 1 centimeter and 3 centimeters. So they are of different sizes. Fine. Let's consider two spheres. A smaller sphere and a bigger one. Smaller sphere's radius is 1 centimeter. Bigger sphere's radius is 3 centimeters. Right. And they are given charges of -1 into 10 power minus 2 Coulomb. So one of them is given a negative charge. Q1 is -1 into 10 power minus 2 coulombs, okay, and the other one is given a positive charge, 5 into 10 power minus 2 coulombs. You can just call them as Q1, Q2 and take the radii as R1, R2 also, not an issue. So let's assume the charge on this sphere is Q1, its radius is R1, and the charge on this sphere is Q2 and its radius is R2. These are connected by a conducting wire. Okay. The final charge on the bigger sphere is, right. Now imagine there is a conducting wire between the two spheres with a switch also. Let's say initially the switch is open. When the switch is open, the charges cannot combine. The spheres cannot exchange any charges. Fine. Now once the switch is closed, one of them is positively charged, the other is negatively charged, so some charge exchange will definitely happen. Can one of you quickly tell me in the chat, why do charges move from one place to another? Or why should these two spheres exchange any charges? Okay, I'll give you all a few seconds. Why will conductors exchange charges? Okay, basically charge flows from one place to another whenever there is an electric field, right? And if there is an electric field, there is a potential difference. Now in this question clearly one charge is negative, one charge is positive. So one sphere is at negative potential, the other sphere is at positive potential. So there's definitely a potential difference between these two spheres, and if there is a potential difference, there will be some transfer of charges. And till when will the charges be exchanged? Till the potentials of both the spheres become equal. Okay. So let's say the final charge on each sphere is capital Q1 and capital Q2. Okay. Initial charges I have taken as small q1 and small q2. Final charges, let them be capital Q1 and capital Q2. Now the charges will keep getting transferred from one sphere to the other till their potentials become equal. So potential of the first sphere should become equal to potential of the second sphere finally. Okay. Yeah. Kangna has given the answer, jab tak potential difference same nahi hota. You are absolutely correct. The charges will keep getting transferred till the potentials become equal. Okay. So the final potential of the first sphere, what is the formula for potential on the surface of a sphere? KQ by R, where R is the radius of the sphere. And K is Coulomb's constant, which is 1 by 4 pi epsilon naught. So the final potential of the first sphere becomes KQ1 by R1. Radius of the first sphere is 1 centimeter. I'm writing it as it is. should become equal to final potential of the second sphere, kq2 divided by r2. r2 is 3 centimeters. I'm not bothering to change the units of the radius because it is going to get cancelled anyway. Okay, and Coulomb's constant k will also get cancelled. So 3q1 becomes equal to q2. That will be the ratio of final charges on the spheres. Okay, good. The initial charges on them are given as -1 into 10 power minus 2 Coulomb and 5 into 10 power minus 2 Coulomb. Now, what is the total charge on both the spheres combined? You add these two, it becomes 4 into 10 power minus 2 coulombs. That's the net charge on this system. That net charge has to distribute on the sphere such that 3q1 is equal to q2. Okay, so q2 should be 3 times of q1. So you can assume the charges like this: q1 on one of the spheres, 3q1 on the other sphere. Therefore, you have to split the charge in the ratio 1:3. Now the total charge is 4 into 10 power minus 2 coulombs. How will you split it in the ratio 1:3? On one of them, the charge will be 1 into, on one of them, the charge q1 will be 1 into 10 power minus 2 coulombs, and on the other one, the charge q2, which is 3 times of q1, will be 3 into 10 power minus 2 coulombs. Okay, that way you can split the total charge in the ratio that you have derived by equating the final potentials. So the question is asking the final charge on the bigger sphere. The bigger sphere is the one which has 3q1 charge, which is 3 into 10 power minus 2 coulombs. So that will be the correct answer. Right. So Kangana is asking, are we only going to practice questions or will study the concepts too? This is a PYQ session basically, so we'll only be solving questions. We'll briefly recollect the concept related to that question. Fine. The next question here says, okay, it's about electric field. The electric field at a distance 3r by 2 from the center of a charged conducting spherical shell of radius r is E. Okay. When it comes to physics, no, you first need to visualize the situation before you start solving a problem. Okay. So here they are talking about a charged conducting spherical shell of radius r. So imagine a charged conducting shell. Let's say it has positive charge. Now, since it's a conducting shell, the charge will be uniformly distributed. It is not influenced by any external agent, so it will be uniformly distributed. They are saying the electric field at a distance 3r by 2 from its center is E. Okay. Now its radius is r. Then 3r by 2 is 1.5 times of r. That will be outside the shell, maybe somewhere here. The electric field at this point is given as E. Okay. They are asking how much is the electric field at a distance r by 2 from the center of the sphere. Okay. This is an easy question actually. Now you consider a point at a distance r by 2 from the center of the sphere. That point will be inside the sphere, okay, because the radius is r. Can one of you quickly respond in the chat? How much is the electric field inside a uniformly charged spherical shell? Electric field inside a uniformly charged spherical shell. Right. You must have proved this using Gauss law. We know that the electric field inside a uniformly charged spherical shell is 0. So the answer to this question will be the first option, 0. Okay. But suppose they ask you something else related to this. Like they have given you the electric field at a distance 3r by 2 as E. And let's say they ask you how much is the electric field on its surface. How to calculate or how to answer such questions. Now E is the electric field at a distance 3r by 2, which is outside the sphere, which is a point outside the sphere. and electric field outside a uniformly charged sphere is given by the formula kq by small r, where small r is the distance from the center of the sphere to the point where you are calculating the electric field. Okay, now this distance, okay, you can say that kq by the distance 3r by 2 is E. Okay, sorry, I wrote the formula for potential, my bad. The formula for electric field at a distance or at a point outside the sphere is kq by r square, right? So electric field at a distance 3r by 2, which is given as E, then becomes kq by 3r by 2 whole square. Okay, and suppose you are asked to find out the electric field on the surface of the shell. On the surface of the shell, the formula for electric field is kq by capital R square, right? Now based on this E is equal to kq by 3r by 2 whole square, you can get how much is kq by r square, and that will be the electric field on the surface of the shell. So that way you can tell the electric field anywhere else also. Okay. Moving on to the next question. If closed integral E dot ds is equal to 0 over a surface. Fine. Now closed integral E dot ds is equal to 0. What does this indicate, or what does this mean? Basically, integral E dot ds is the electric flux passing through a surface. Now if you are given closed integral E dot ds, that means it is the flux passing through a closed surface. Now based on this flux passing through a closed surface, you can understand that this is a question based on Gauss law. Okay, Pooja is asking me to explain in Hindi. I can try to explain in Hindi, but मेरी हिंदी उतनी अच्छी नहीं है. I think you will find it more funny. So कोशिश करूँगा. So integral E dot ds basically क्या होता है? Flux through closed surface. Now look at the options. The first option, if this happens, the electric field inside the surface is necessarily uniform. Okay, closed integral E dot ds, flux through the closed surface is 0, and from Gauss law we know that closed integral E dot ds is nothing but charge enclosed divided by epsilon naught. Now if this is 0, we can only conclude that the charge enclosed by this surface is 0. Okay, we can't say anything more than that. Now the first option is saying the electric field inside the surface is necessarily uniform. Whether the field is uniform or non-uniform depends on the distribution of charge. Okay, but on the basis of net flux, we cannot comment on the distribution of charge. We can tell how much is the total charge inside the surface, but we don't know the distribution. So field uniform hai or non-uniform hai, we cannot comment on that. Next, the number of flux lines entering the surface must be equal to number of flux lines leaving it. Flux lines are nothing but field lines. Now net electric flux through this surface is 0. That means that means the total number of lines entering the surface should be equal to total number of lines leaving. That means negative flux should be equal to positive flux. Okay, so the second statement is definitely correct. Let us look at the third and fourth statements also. The magnitude of electric field on the surface is constant. Now we cannot comment on whether the electric field is constant or not. As I said, we don't know the charge distribution. We only know that the total charge inside the closed surface is 0. Okay, so we cannot comment on the electric field. Next, all the charges must necessarily be inside the surface. There is no need of this also, because according to Gauss law, the net flux through a closed surface depends only on the charge enclosed by it. There may be charges outside the surface also. But जितना भी चार्ज आउटसाइड द सरफेस है वो चार्ज नेट फ्लक्स को कंट्रीब्यूट नहीं करेगा. Okay, net flux arises only due to charge enclosed in the surface. Okay, so all charges must be necessarily inside the surface. This is not necessary. Okay. Next. Okay. आरती कुमारी is asking, सर जी कल से हिंदी में पढ़ाइएगा. ओके, अब एक दिन में उतना हिंदी कैसे सीख सकता हूँ मैं? जितना हिंदी मुझे आता है उतना कोशिश करूँगा. ओके. नेक्स्ट क्वेश्चन. An electric dipole, okay, this question is related to dipole, is placed at an angle 30 degrees with an electric field of intensity 2 into 10 power 5 Newton per Coulomb. Okay, so they have given you the magnitude of electric field and the angle at which a dipole is aligned with this electric field. Fine. Let's assume the electric field is directed to the right. Let's say this is one of the field lines and the dipole is placed at an angle 30 degrees. With the electric field. It experiences a total torque of 4 Newton meter. It experiences a total torque of 4 Newton meter. Now, we have a formula for torque acting on a dipole placed in a uniform external field. Here they have not told that the electric field is uniform, but you have to assume. Otherwise, you cannot solve this problem. Okay. Now, torque on an electric dipole, the vector formula is P cross E, but here in the question, they are not talking about the direction of torque, they are only talking about magnitude. So, magnitude of torque will be PE sin theta, where P is the dipole moment, E is electric field, and theta is the angle between them. Right? They have given that it experiences a net torque of 4 Newton meter. So, 4 should be equal to P multiplied with the electric field is 2 into 10 power 5 Newton per Coulomb. Sin theta, sin angle between dipole moment and electric field is 30 degrees. Sin 30 degrees basically is 1 by 2. So 2 and 1 by 2 can be cancelled. You will be left with 4 is equal to P into 10 power 5. Therefore, the dipole moment P is 4 into 10 power minus 5. And dipole moment का unit क्या होता है? Coulomb meter. Right. Next, they are asking you about the magnitude of charge on the dipole. Okay, they have given you the length of the dipole as 2 centimeters and are asking you about the charge on the dipole. Now, we know dipole moment, and dipole moment is nothing but charge on the dipole multiplied with the length of the dipole. Simple. Okay, therefore, you can say that the charge on the dipole will be the dipole moment 4 into 10 power minus 5 divided by the length of the dipole 2 centimeters. Now, we will have to convert this to meters because we expect the answer in coulombs. Okay, we want to give the answer in coulombs. So, you'll have to convert the charge, you'll have to convert the length to SI units. Centimeter is 10 power minus 2 meters. So, 4 by 2, this effectively becomes, I'll write the answer here. This effectively becomes 2 into 10 power minus 3 coulombs, and 10 power minus 3 is given the name milli. So, the charge on the dipole becomes 2 millicoulombs. Simple. Let's move on to the next question. Okay, 2 point charges minus Q and plus Q. Okay, diagram भी दिया हुआ है. They are placed at a distance L. L is the distance between the charges. Fine. The magnitude of electric field intensity at a distance capital R, where capital R is much greater than L. varies as. Okay. So they have given you a system of two equal and opposite charges separated by some distance. And they are asking you about the electric field that it creates at a large distance from the system. Now this is actually a trick question. Because the distance at which the field is asked is very large, what you can do is you can treat this system essentially as a dipole. Okay, one negative charge, one positive charge separated by some distance. Okay, and they are asking you to calculate the electric field at a large distance. Not even calculate, they're just asking you how the field depends on the distance. Okay, now the electric field produced by an electric dipole on its axis, okay, at a large distance on its axis, if you consider, it is 2kp divided by r cube. On the equatorial line at a large distance, if you consider, it is minus kp divided by r cube, taking it as a vector, right? But wherever you try to find out the electric field, it will be inversely proportional to cube of the distance if the distance is very large compared to the size of the dipole. And in this question they have given the same condition, okay, that the distance is very large compared to the length of the dipole. Therefore it will be inversely proportional to r cube. Good, good. Many of you have given the answer as C. Correct. Let's move on to the next question. Two point charges A and B having charges plus Q and minus Q. Okay, so they have given two equal and opposite charges, are placed at a certain distance apart, and the force acting between them is F. Okay, so this question is talking about force between charges, point charges that too. And how do we calculate force between point charges? Using the basic Coulomb's law. So it's related to the formula F is equal to K Q1 Q2 divided by R square. Okay. The force between them is given F. If 25% of charge of A is transferred to B, then how much does the force become? Right. So they are only talking about magnitude of the force. So the exact direction and all is not necessary. So we'll substitute the magnitudes of charges. Sign can be ignored. The initial force between the two charges, which is given as F, वो कितना होगा? K, one charge is Q, magnitude of the other charge is also Q, divided by some distance. Okay, let's take the distance as D, so this is F. Now what they are doing is 25% of charge of A is transferred to B. A का charge कितना है? Q. उसमें 25% means 1/4. वो कितना होगा? Q by 4. Okay, so A में से Q by 4 charge निकाल के Q को दिया गया, okay, और Q में add किया गया. तो what will be the charge left on A? From Q, if you remove Q by 4, the charge left on A will be 3Q by 4. And that Q by 4 which is removed from A is given to B. Now B already had a charge of minus Q. You are adding a charge of Q by 4 on it. Then what does the charge of B become? Minus 3Q by 4. So after the charge rearrangement, the final charges are 3Q by 4 and minus 3Q by 4. Okay. So the magnitude of charge has changed. Distance उतना ही रहेगा लेकिन charges बदल गए. तो क्या होगा? The force between them will change. So the new force between them, let's call it F dash, will be K. One charge is 3Q by 4. The other charge is also magnitude is 3Q by 4, and divided by the square of the distance between them. And 3 by 4 becomes 9 by 16 KQ square by D square. So, and KQ square by D square is nothing but the initial force that was acting between them. So the answer will be 9 by 16 times of F. Okay. Yeah, Sanya, Arti, J, you have all given the correct answers. Good. Right. Let's move on to the next question. A sphere encloses an electric dipole. इसका मतलब क्या है? The dipole is completely inside the sphere. Let's visualize the situation. Okay. And consider a dipole inside it. We don't know how exactly it is placed. So let's say there is a dipole like this. Dipole is basically a system of two equal and opposite charges, but the net charge on the dipole is 0. Right. They have given the charges plus and minus 3 into 10 power minus 6 coulombs. So one charge is 3 microcoulombs, the other charge is minus 3 microcoulombs. They are asking you what is the total electric flux through the sphere. Okay. So question is about total flux through a sphere. So what is the concept on which this is based? Sphere क्या होता है? Closed surface होता है. And you need electric flux through the sphere. Now which concept talks about net electric flux through a closed surface? Gauss law. Okay. And Gauss law states that the net electric flux through a closed surface is the total charge enclosed by the surface divided by epsilon naught. Okay. अब इस sphere के अंदर क्या है? एक dipole है. Okay, the dipole is completely inside the sphere. So there is one negative charge and an equal amount of positive charge. Okay. Yeah, Aarti Kumari, your answer is correct. Therefore, the net charge enclosed here becomes 0. So total electric flux भी 0 ही होना चाहिए. Okay. Now, in the same situation, you can consider small variations also. Let's say instead of completely keeping the dipole inside the sphere, they keep one charge inside, one charge outside. Okay, I'll just rearrange this system to help you visualize what I'm talking about. Suppose the situation is like this. Okay, some charge inside, some charge outside, and they ask you what is the net electric flux through this sphere. Now how will you answer? The concept is the same. You have to see what is the charge enclosed by the sphere, because sphere is a closed surface, right? So you will answer based on Gauss law only. But if they ask you a question like this, that means they are indirectly testing you whether you know what to do with the external charge or not. Okay, but we know from Gauss law that the net electric flux through a closed surface will be charge enclosed by the surface divided by epsilon naught. Okay, let me just explain some concept here, some additional concept here. Why is the net electric flux only due to internal charges? Why not external charges? Let us talk about that for a minute. Okay, listen to this carefully, all of you. Suppose there is a charge Q outside this sphere. Now this sphere is a Gaussian surface. Basically it's an imaginary surface. Okay. Now this charge Q which is outside the sphere, okay, actually surface sphere ही नहीं, कोई भी shape का हो सकता है. Okay, you can consider any random shape. The charge Q creates electric flux. Okay, means it creates field lines. You visualize the electric field lines produced by the charge Q. Some of them will be passing through the surface like this. Right. Now what was the thing that we wanted to discuss? Whether or why external charges do not contribute to net electric flux through a closed surface. Now observe carefully. There are some points on this surface where the field lines enter into the surface. Okay, precisely there are 5 points here. Okay, आरती कुमारी saying इंग्लिश में समझ में उतना नहीं आ रहा है लेकिन क्वेश्चन बन रहा है. Okay. See, if you want, I mean, some idea if you did not understand, and if you want me to explain that in Hindi once again, I can try. Okay. Next. So here if you observe, there are 5 points through which field lines are entering into this closed surface. So on that part of the surface, there will be a negative flux due to this external charge. But if you observe carefully, since this is a closed surface, there will be an equal number of points. Okay, there will be an equal number of points where the field lines are leaving the closed surface. And at those points, there will be positive electric flux. Okay. अब क्योंकि यह चार्ज सरफेस के बाहर है, जितने भी फील्ड लाइंस सरफेस के अंदर आएंगे उतने ही फील्ड लाइन सरफेस के बाहर भी जाना चाहिए. ओके, सो the negative flux created by this charge will be equal to the positive flux created by it. That is why external charges never contribute to the net electric flux on a closed surface. क्या इसका मतलब ये है कि external charge flux create ही नहीं करता, produce ही नहीं करता? That is wrong. External charges can produce flux, okay, but they produce equal amounts of negative and positive flux. Fine. Let's move on to the next question. Two charges, 2 microcoulomb and 8 microcoulomb, both positive charges, they are separated by some distance. This question is about neutral point. Okay. Neutral point का concept gravitation में भी like useful है. Both, yeah, in electrostatics, gravitation, even in magnetism. Fine. तो neutral point होता क्या है? Neutral point is basically a point where the net field is zero. अगर ग्रेविटेशन में पूछा गया तो ग्रेविटेशनल फील्ड जीरो, इलेक्ट्रोस्टैटिक्स में पूछा गया तो दैट मीन्स द नेट इलेक्ट्रिक फील्ड शुड बी जीरो. सो net electric field produced by these charges must be zero. They want you to find out where the neutral point is. Okay, I'll explain this question conceptually, and at the end I'll give you a formula also which can help you derive the distance of neutral point directly. Let's consider the two charges first, separated by some distance. Okay. One charge is 2 microcoulombs. Let's just call it as 2q. And the other charge is 8q, 8 microcoulombs. Fine. Because finally you will realize that it's just the ratio of charges that matters. Exact charge does not matter. Okay, neutral point find out करने के लिए सिर्फ ratio of charge जानना चाहिए हमें. Okay, both are positive charges. They will create fields. Positive charges create fields directed away from themselves. Right. अब neutral point produced by two charges can only lie along the line connecting the charges. Okay, line के बाहर तो हो ही नहीं सकता, because if one charge produces a field this way, another charge produces a field this way, these two have no chance of getting cancelled. Okay, if they don't get cancelled, how will the net field become zero? So net field becoming zero is only possible along the line connecting the charges. Right. Now the line connecting the charges can be extended up to infinity on either side. Right. So in order to solve questions of this kind, based on neutral point or based on net electric field or net gravitational field also for that matter, you will have to split the space. Okay, you will have to split space into three parts. What are the three parts? One part here, okay, let's call this as point A, which is to the left of both the charges. Now think about the field produced there. 2q, since it's a positive charge, will produce a field directed away from itself. 8q is also a positive charge. It will also produce a field directed away from itself. दोनों field एक ही direction में है तो cancel होने का chance ही नहीं है. So the net field here cannot be zero. So anywhere on the extreme left, you cannot find the neutral point. Okay. Now look at the extreme right. Let's call this point as B. Both the charges are positive. 2q will produce a field there away from itself. Positive charge kabhi bhi, okay, that much Hindi I don't know. Positive charge always produces a field away from itself. 8q will also produce a field away from itself. अब दोनों fields एक ही direction में है, both are towards right, so they cannot get cancelled. B cannot be a neutral point. Okay, means you cannot expect to find a neutral point anywhere on the extreme right of this system. Now consider a point between, okay, random point between the two charges. 2q being a positive charge produces a field directed away from itself, so towards right. 8q being a positive charge produces a field directed away from itself, so towards left. So in the space between the two charges, their electric fields are in opposite directions. तो fields cancel होने का chance तो है. Okay? I'm not saying they will cancel everywhere, but there is a chance that they will cancel. Fine. But fields cancel होने के लिए direction should be opposite, but strength same होना चाहिए, magnitude same होना चाहिए. Okay. Now these are point charges. What is the formula for electric field produced by a point charge? KQ divided by R square. And just a small tip that I want to give you. Instead of remembering the formula as KQ by R square, remember it as KQ by X square. Okay, why I am telling you this is because when it comes to spheres, okay, from my experience I have observed, when finding the electric field produced by a sphere, see, in most textbooks you will find the formula as KQ by R square. In a hurry, okay, examination tension में students क्या करते हैं? They substitute, they know the formula KQ by R square, but to find out the field somewhere outside the sphere or maybe inside the sphere also, in a hurry they substitute the radius of the sphere. Okay, they remember the formula as KQ by R square and question में दिया जाता है radius R is this much. So in exam tension they substitute the radius in place of the distance. So there's a chance that you could go wrong. It's better if you remember the formula as KQ by X square, where X is the distance from the center of the sphere or the point charge. Okay. Now we need to locate the neutral point here. You look at this formula for electric field. Electric field produced by a point charge is inversely proportional to square of the distance from the point charge. So closer you are to the point charge, stronger will be the electric field. Fine. So at points very close to 2q, the field produced by 2q will be very strong, but field produced by 8q will be weak. So net field will be towards right. Okay. Now you move to a point very close to 8q. There 8q will produce a very strong field because the distance is very less. 2q will produce a weak field because the distance from 2q is more. So the net field there close to 8q will be to the left. Fine. But somewhere between, okay, along the line joining them, somewhere between them, there will definitely be a point where the net field is 0. Okay. Let the distance of that point, let the distance of the neutral point from 2q be x. Then how much will be the distance of the neutral point from the other charge? 6 minus x in centimeters. Okay. Now the net field has to be 0, means the field produced by 2q should balance the field produced by 8q. Their magnitude should be equal. Let us equate the magnitudes now. So k multiplied with 2q divided by x square should be equal to field produced by the other charge, k multiplied with 8q divided by 6 minus x whole square. Okay, Liam Livingstone is asking please explain in Hindi. अब पूरा का पूरा हिंदी में तो नहीं बोल सकता हूँ मैं, जितना हो सकता है उतना कोशिश करूँगा. Right. So if you cancel k and q, you will be left with 2 and 8 also can be cancelled. You will be left with 4 here. So this equation changes to 1 by x square is equal to 4 divided by 6 minus x whole square. How did we get this? we just balance the electric fields produced by the two charges which were in opposite directions. Now again, in a hurry, some of you may have this tendency to send 6 minus x whole square this side, x square this side, and evaluate the quadratic equation. That will be a lengthy procedure, okay, and it's not necessary also. Okay, so what you can do here is just take square root on both sides. Fine. Then what does this expression change to? Under root 1 by x square becomes 1 by x, and under root 4 by 6 minus x whole square. Root 4 is 2 divided by 6 minus x whole square, under root is 6 minus x. Now you just cross multiply, you get 6 minus x is equal to 2x. So 6 is equal to 3x. That means x is equal to 2 centimeters. Therefore, the distance of the neutral point from the 2q charge is 2 centimeters. So remaining distance will become 4 centimeters. Okay. Now I told you that I'll give you a formula to quickly derive the position of the neutral point. Now remember, this formula works if the charges are of the same sign. So you can use this formula in gravitation. In gravitation, masses are anyway positive all the time. Okay. In electrostatics, this formula can be used if the charges are of the same sign. And what is the formula? The neutral point between two like charges. Okay. Let's take the charges as q1 and q2. The neutral point between two like charges q1, q2 divides the line joining them in the ratio root of q1 is to root of q2. Okay. Let's apply that formula to this question. One charge is 2q, and on the other side the charge is 8q. Charges are 2 and 8. So the neutral point divides the line joining them in the ratio root 2 is to root 8. Okay. So root 2 is to root 8, you can take it as square root of 2 is to 8. 2 is to 8 is 1 is to 4. Square root of 1 is to 4 becomes 1 is to 2. Fine. So the neutral point should be dividing the line connecting them in the ratio 1 is to 2. Now, अब total distance कितना दिया हुआ है? 6 centimeters. 6 centimeters को 1 is to 2 ratio में split करना है. Okay, so 3 parts में split करना है. 6 divided by 3 parts, divided into 3 parts becomes 2 centimeters. So 2 centimeters on one side, 4 centimeters on the other side. That is where you will find the neutral point. If you want to use this in gravitation, it will be square root of mass m1 to square root of mass m2. Simple. Right. Next question. A charge q is placed in a uniform electric distance traveled करने के बाद उसका kinetic energy क्या होगा? Okay. Fine. Now the formula for kinetic energy is half mv square. तो इसमें हमको पहले चार्ज का स्पीड कैलकुलेट करना पड़ेगा. ओके, एंड देन हाफ mv square will give us the kinetic energy. But you look at the options once. None of the options is in terms of mass of the charge, right? So see, you can calculate speed and use the formula half mv square. उससे बनेगा. Okay, mass will get cancelled, but there is another approach also that you can take. What is the other approach? How do you get kinetic energy? Now kinetic energy calculate करने के लिए कई तरीके हैं. Like you can use power and relate it to energy. You can use speed and get energy from it, kinetic energy from it. You can use work and get kinetic energy from it. Okay. In the chapter work, energy, power, you must have studied work kinetic energy theorem. What does it state? Total work done on a system is equal to the change in kinetic energy of the system. And change in kinetic energy कैसे एक्सप्रेस करते हैं? फाइनल काइनेटिक एनर्जी माइनस इनिशियल काइनेटिक एनर्जी. अब दे आर सेइंग दैट दिस चार्ज इज जस्ट रिलीज्ड. चार्ज को रिलीज किया गया, मतलब यू विल अज्यूम दैट इनिशियल काइनेटिक एनर्जी इज जीरो. ओके, ये अज्यूम करना है कि इनिशियली वो मूव नहीं कर रहा था. अगर मूव नहीं कर रहा है तो काइनेटिक एनर्जी जीरो. Therefore work done itself is the final kinetic energy. And how do you calculate work done? Again, for work there are two different formulas. अगर फोर्स वेरिएबल है तो इंटीग्रल एफ डॉट डी एस, अगर फोर्स कांस्टेंट है तो इंटीग्रेट करने की ज़रूरत नहीं पड़ेगी. यू कैन जस्ट यूज एफ डॉट एस, फोर्स डॉट डिस्प्लेसमेंट. नाउ इन दिस केस द इलेक्ट्रिक फील्ड इज यूनिफॉर्म, चार्ज इज फिक्स्ड. सो इफ इलेक्ट्रिक फील्ड इज यूनिफॉर्म, the force experienced by the charge QE will also be uniform. फील्ड हर जगह एक ही है तो फोर्स Q इंटू ई वो भी हर जगह एक ही होगा ना, along with direction it is uniform. So you can use this formula F dot S to calculate the work done here. Fine. अब फोर्स का मैग्नीट्यूड तो हमें पता है, and they have given in the question that it travels a distance y. Now if an object is starting from rest and it experiences constant force, it will move in a straight line. Okay, so distance and displacement will be same. If it is moving in a straight line without changing direction, it will, its distance will be equal to displacement. Therefore the displacement here is equal to y. And because the charge is initially at rest, charge अगर initially rest में है तो जिस direction में force लगेगा उसी direction में charge move करेगा. So force and displacement same direction में होंगे. Therefore the work done here becomes, the basic formula is Fs cos theta, the force is QE and the displacement is y. Angle between force and displacement is 0. Cos 0 कितना होता है 1. Therefore the work done is QEY. Work done अगर QEY है तो kinetic energy भी उतना ही होगा. Work kinetic energy theorem. Okay. Some of you have given answers like किसी ने आंसर दिया थर्ड ऑप्शन, किसी ने आंसर दिया है फोर्थ ऑप्शन. ओके, I don't know, I would like to know like how did you calculate, how did you get third or fourth options? But using work energy theorem, it is clear that, this is the easiest approach. If you are comfortable with work energy theorem, this is the easiest approach. Some of you may have tried using equations of kinematics. Okay, fine, let us discuss it that way also. The force on the charge is F is equal to QE. तो चार्ज का एक्सेलरेशन कितना होगा ना. वाई आर वी बॉदर्ड अबाउट एक्सेलरेशन? एक्सेलरेशन कैलकुलेट क्यों करना है? बिकॉज वी वांट काइनेटिक एनर्जी. ओके, विच डिपेंड्स ऑन स्पीड. स्पीड कैलकुलेट करना है तो एक्सेलरेशन जानना पड़ेगा. सो A इज इक्वल टू F बाई एम, न्यूटन सेकेंड लॉ. सो QE बाई एम इज द एक्सेलरेशन. अब इलेक्ट्रिक फील्ड यूनिफॉर्म है तो एक्सेलरेशन भी यूनिफॉर्म ही होगा. और अगर एक्सेलरेशन यूनिफॉर्म है तो हम इक्वेशंस ऑफ काइनेमेटिक्स लगा सकते हैं. नाउ दे हैव आस्क्ड स्पीड, ओके, दे हैव आस्क्ड काइनेटिक एनर्जी आफ्टर ट्रैवलिंग अ डिस्टेंस y. ओके, सो यू हैव टू रिलेट स्पीड टू डिस्टेंस. कौन सा इक्वेशन ऑफ काइनेमेटिक्स स्पीड और डिस्टेंस को रिलेट करता है? द थर्ड इक्वेशन, v square minus u square is 2as. Actually displacement, but in this case we have already discussed that distance displacement will be same. So using v square minus u square, u is 0, charge is released from rest, is equal to 2, acceleration कितना है? QE by m, and displacement question में दिया गया है y. Okay, so v square is 2QEY divided by m. इसका स्क्वायर रूट लेके v निकालने का ज़रूरत ही नहीं है. Why? Because काइनेटिक एनर्जी में v स्क्वायर सब्स्टिट्यूट कर सकते हैं ना डायरेक्टली. Okay, and from this you can say that kinetic energy will be half m multiplied with v square. So half m, v square is, as we have just derived, 2QEY divided by m. 2 and m gets cancelled. The answer this way also will be QEY itself. Okay, so whether you use work energy theorem or you use equations of kinematics, you get the same answer.